In this video the following concepts are studied: velocity, speed, displacement, distance, Pythagorean theorem, etc. In this section we want to examine the velocity of a moving object. Pay attention. Do not confuse velocity with speed. We'll compare the two later, we examine velocity now. We have two types of velocity: instantaneous, and average. Instantaneous velocity is the velocity that a moving object has at one moment, and may have another velocity at another moment. For example, the number that the car odometer shows is the magnitude of the instantaneous velocity. Average velocity. Average velocity is the average of a moving object velocity over a period of time. Tip 1. Whenever we have a time interval in a problem, the average velocity is desired, and if we have a moment in time, the instantaneous velocity is desired. For example, if you say calculate the velocity of a moving object from moment 5 to moment 7, you mean the average velocity between these two moments. And if you say calculate the velocity in moment 6, it is clear that you mean instantaneous velocity. First we limit ourselves to the average velocity. By definition, average velocity indicates how much a moving object moves in a given period of time. Be careful first. Tip 2. Velocity and speed are different. Velocity is the ratio of displacement of an object with respect to time. Speed is the ratio of distance of an object with respect to time. Displacement is a vector. This vector is drawn directly from the primary location to the secondary location. But distance is the length of the path. Distance is scalar. Suppose an object moves first 4 meters, then 5 meters, and then 4 meters. The distance traveled is 13 meters, and has no direction. But the displacement is a vector whose beginning, and, magnitude and direction must be known. In this case the length of the vector is equal to 5 meters, and its direction is in accordance with the figure. In the next example we will compare the two.
Example 1. An object first moves 6 meters in 2 seconds, and then 8 meters in 4 seconds. Calculate the velocity and speed. A. In the first 2 seconds. B. In the next 4 seconds. C. In total time of 6 seconds. In the first 2 seconds, the moving object moves by 6 meters. Because the object has traveled a straight line, so the displacement and the distance are equal. That means 6 meters, so we have. In this case, speed and magnitude of velocity are equal. In the next 4 seconds, the moving object moves by 8 meters. Because the body has taken a straight line, the displacement and the distance are both equal. That means 8 meters, so we have. In this case, speed and magnitude of velocity are equal. Notice the total movement. The total time is equal to 6 seconds. During this time interval, moving object traveled 14 meters. Speed is equal to To calculate velocity, we need to calculate displacement, which is a vector. To calculate this vector, we need to calculate the hypotenuse of the right triangle. To do this, we need the Pythagorean theorem. This theorem says the sum of the squares on the legs of a right triangle is equal to the square on the hypotenuse. Please see carefully. So we have Tip 3. If an object moves in a straight line, the magnitude of the displacement and the distance are equal, otherwise the distance is greater than the magnitude of the displacement. So in a certain period of time, velocity is equal or less than magnitude of average speed. Example 2. The equation of position of a moving object in SI is as follows. Calculate its velocity from moment 1 second to moment 3 second. We calculate the moving place in both moments. Instead of t we put 1 in equation and do the calculation. The number 6 is obtained, that is at moment 1, it is moving at a location 6 meters from the origin of the coordinates. Instead of t we put 3 in equation and do the calculation. The number 28 is obtained, that is in moment 3 it is moving in a place 28 meters from the origin of the coordinates. To calculate the measure of the displacement, we subtract 2 position of the car at 2 different moments. We denote this value by delta x. The delta sign does not worry you, it is just a sign to show change or difference. The time interval is equal to the difference of the time between 2 moments 1 and 3 seconds, we denote it by delta t. The average speed or velocity between these 2 moments is obtained by the following expression. Which is equal to 11 meters per second. Note that this value indicates the average of displacement during this time period. The moving object is displaced 11 meters in any second. But you should note that the moving speed is not constant. Do you know how we detected the speed is not constant? The answer is in the equation of motion. We have already said that if the power of t in the equation of motion is other than 1, the velocity is not constant. A conceptual point is made here. What does the number 11 meters per second indicate? If the car speed is not constant, what is the use of this number? The answer to this question is in the sense of average speed. In fact, our example car, although it had different speeds at different times, moved 22 meters in 2 seconds. On the other hand, if another car were moving at a constant speed of 11 meters per second, it would move the same amount, that is 22 meters, in the same period of 2 seconds, and this is the concept of average speed. You may have a question: can we calculate the instantaneous velocity? The answer is yes. But to do this we need a mathematical method. A method called derivative. A separate math course is required to master this topic. But we will also pay attention to the mathematical aspect of each problem as needed. In the next part, we will explain this method for a polynomial, and we will use it in physical issues.